AGHAMAZING, my dear students! Welcome back to our science video lesson. I am your science teacher, Teacher Larry, and welcome to AGHAMAZING way of learning science. In our previous video lesson, we discussed the different characteristics of waves. Just like in understanding sounds, we will use the different concepts about waves to study our new lessons in this video, which is all about the characteristics of light.
Look at the things around you. Did you know that life cannot exist without light? Nearly everything you use depends on light in some way. Light keeps us warm. It powers some of the things we use. It also helps the plants to grow. Without light, you will not be able to see beautiful colors of a rainbow, a sunset, and the moon in the night sky, or even see your way around. These are all possible because of the presence of visible light. But how does a light behave so that we can see these beautiful creations?
Light is an electromagnetic wave. This means that it does not need a medium in order to propagate. Light travels in straight path. In vacuum, light has a speed of 299,792,458 meters per second. It takes 499 seconds or approximately 8 minutes for the light to travel from the sun to the earth. Light is a form of energy made of photons. Photons are the smallest unit of visible light. Our main source of light energy is the sun. The sun is an example of natural source of light. The sun is also considered a luminous body. A luminous body is an object capable of producing its own light. Other sources such as lamp, flashlight, and candles are examples of artificial sources of light. Different scientists spend a lot of time in understanding how light behaves. These include Isaac Newton, who believed the light behaves like a particles; Christian Huygens, who believes that light behaves like a wave; Louis de Broglie, who believes that the light can be a particles and a wave; and James Clerk Maxwell, who proposed the electromagnetic theory of light, among others. Their combined investigations enables us to understand the behavior of light even better. Light is considered to have a dual nature. It behaves as a tiny particle called photon and also behaves as a wave. Light is formed by the vibration of electric and magnetic fields. Therefore, it is a form of electromagnetic radiation. The electromagnetic spectrum is where the electromagnetic waves are arranged in increasing frequency. Observe the illustration. Which wave has the lowest frequency? How about the wave that has the highest frequency? As can be seen in the illustration, radio waves has the lowest frequency, and gamma rays have the highest frequency. The only frequency of the electromagnetic waves that is visible to the human eye is called the visible spectrum. The visible spectrum is also called as the white light. When white light strikes into a prism, it splits into visible light colors in the electromagnetic spectrum. This phenomenon in which prism separates white light into component colors is called dispersion. The component colors of white light include red, orange, yellow, green, blue, indigo, and violet. These component colors are arranged according to an increasing frequency in a visible light spectrum. Light is a form of energy that travels in electromagnetic waves. It behaves like a wave. Thus, it also has a wavelength, frequency, and amplitude. These properties have something to do with the special characteristic of lights, which include intensity and color. Let us first discuss the intensity of light. The light intensity is the power of light. It is the quantity that measures the amount of light illuminating a surface. The science of measuring the intensity or brightness of light is called photometry. Brightness is a qualitative expression of light intensity. It is the visual perception in which a light source appears to be emitting light or a surface to be reflecting light. Since brightness is qualitative and is dependent on the perception of an individual, brightness can be expressed quantitatively using luminous intensity. Luminous intensity is the amount of light that the object produces. It is measured in terms of candela. The brightness of light depends on how far you are from the source. Observe the following scenario, in which scenario you will see a brighter light. Yes, it is in scenario B. The closer you are to the source of light, the brighter is the light that you will see. On the other hand, if you are farther from the source, the dimmer is the light that you will see. Always remember that the intensity of light depends upon the amount of light or the number of photons that pass a certain area or space. The intensity or brightness of light is also related to the wave's amplitude. The higher amplitude corresponds to a brighter light, while the lower amplitude corresponds to a dimmer light. The next characteristics of light is color. You already know that the visible light is the only electromagnetic wave that can be seen by the human eye. The component color of visible light can be seen in a visible spectrum. The color of the light depends on the frequency or wavelength of the radiation that reaches the eye. Visible light falls in the wavelength range of 400 nanometers to 700 nanometers. Observe this illustration. What can you say about the relationship of frequency and wavelength? Very good. As the wavelength decreases, the frequency increases. Again, observe this illustration. Which color has the longest wavelength? How about the shortest wavelength? You are right. Red has the longest wavelength and violet has the shortest wavelength. Now, which color has the lowest frequency? And how about the color that has the highest frequency? Very good. Red has the lowest frequency and violet has the highest frequency. In general, the color white represents the combination of all the wavelengths of visible light, while black is the absence of the wavelengths. And that ends our science visual lesson. In our next video lesson, we will be discussing heat and the different forms of heat transfer. See you in our next science visual lesson.